Hello everyone, my name is Diego and today I'm gonna talk about text file input output. Now I will explain how to use the scanner class to read numeric and string types from a file. So in this example, first I am declaring the file and scanner variables. Then inside the try block, I'm going to initialize the file and scanner object. So the file is gonna represent the file and the scanner is gonna read it. Then I'm gonna use a while loop, and that's gonna allow me to read through the file token by token. And a token is simply a chunk of data that the scanner reads. Each token can be a string, integer, or double. Now I will explain how to use the print writer class to write numeric and string types to a file. And there are a few things we need to take into account when we work with the print writer. Unlike other writers, the print writer converts the primitive data into the text format. It then writes that formatted data to the writer. Also, the print writer class does not throw any input-output exception. Instead, we need to use the check error method to find any error in it. In this example, first I'm gonna declare the print writer class or object, Inside the try block, I'm gonna initialize it with the file writer object passed as a parameter. The file writer tells the print writer that the file to what file to write to, and the true argument enables append mode, meaning that new data will be added to the file instead of overwriting its existing contents. So now that we have the print writer set up, we can start writing the data. The print writer class offers several methods for this. In my example, I'm using the print line method, which writes data followed by a new line. But we can also use just the print method, which writes data without a new line. So in my example here, I'm gonna write a string to the file using the print line method. And now if I want to add an integer, I'm gonna also use the print line method. But here I'm assigning the integer to the h variable, and I'm just gonna add it to the print line method. For the double, it's pretty much the same. We're assigning the double value to the height variable and just adding it to the print line method. So in programming, we can use similar code to read from a file, the console, or the web, because they all work with streams. A stream is a flow of data, whether it's from a file, user input, or a web response. In Java, for example, classes like buffer reader or scanner provide a consistent way to read text from any of these sources. The code structure remains similar because Java abstracts the details of where the data comes from. You don't have to worry about how the data is fetched, whether it's stored on disk, entered by a user, or downloaded from the internet. For example, reading a line of text uses methods like readLine or nextLine, no matter the source. These abstractions allows you to focus on processing the data, not how it's delivered. So the key is that Java treats these sources uniformly through streams, making it simple to write flexible and reusable code. Now I will explain the concept of data buffering and show how data can be buffered in Java. A buffer is a memory area that stores streams of data, which is a flow of data, a continuous flow of data, from input devices, files, or any such source from where the data is being read temporarily while it is being transferred between two devices or between a device and an application. From the buffer, the streams of data are collected and stored in variables. This makes data transfer more efficient because if we were to store a string into a string variable, when we enter a string from the keyboard, the string wouldn't be stored directly into the string variable. If that happened, it would not be possible to store the complete string because the data enter from the keyboard comes as a stream of data. If the data was stored directly in the variable and we wanted to store the string ABCD, when we pressed A on the keyboard, it would be stored in the variable first. Then when we press the next character B, the A would be overwritten by B, and so on. However, when we use a buffer, each character is stored in the buffer one by one in consecutive memory locations, thus converting the stream of data into a single solid value. So in this example, we are creating a buffer reader to read input from the console, and the system in is the predefined input stream in Java that represents the keyboard input. The input stream reader is a bridge class that converts an input stream, which is the system in, which reads bytes, into a reader, which reads characters. And then the buffer reader buffers the character data, allowing us to read whole lines efficiently. So what this means is that the buffer reader is gonna scan the values and it will store them in the buffer. Then when we use the read line method, it takes the entire value from the buffer and stores it in the variable, in this case name. Now I will explain why a finally block or a try with resources is necessary with the file input output. So when you open a file in Java using a file reader or a buffer reader, you're using system resources like file handles. These resources are limited. If you don't close them properly, you might run into problems like depleting the system's file handles, locking a file so other programs or parts of your code can access it, and overall causing resource leak, which can crash or slow down your program. So Java provides two solutions for this problem. One is using the try catch finally, which in the finally catch is always gonna execute at the end whether an exception is thrown or not, and we're gonna use an if statement checking if the scanner is null, and if it is, we're just gonna use the scanner that close method. Another solution for this problem is the try with resources. It is much of a more modern solution, and the resource is gonna close automatically at the end of the try block. You don't need a finally block or even explicit close call. The only requirement is that the resource implements the auto-closable interface. So it is pretty much like a try catch block. The only difference is that we're gonna initialize the resource inside a parenthesis next to the try keyword.